Hi everyone, today I'm going to talk about how to simply drive a brushless DC motor or any other type of brushless motors like brushless AC motors or brushless hobby motors using Solo in the simplest form possible. So when I'm talking about Solo, I'm talking about this module that you can see. It's a control board designed to control different types of electrical motors, and it's designed to be simple to use with also some advanced features. And in this tutorial, I'm intending to show the simplest and the easiest way of using Solo and driving a brushless motor with it, so that you can see how far you can go with simplicity and ease of use with this module particularly. So what we're gonna use here is gonna be this type of motor, which is a brushless DC motor, an industrial grade brushless DC motor with 36 volt as a nominal voltage and 3000 RPM. You can see the model number and everything here. So I'm gonna firstly drive this motor in a speed control mode, and the interesting thing will be I'm gonna put Solo into field oriented control mode, and I'm gonna show you how manually you can tune Solo to do field oriented control for you. The next thing you're gonna need will be practically one potentiometer for tuning the speed, increasing the speed or decreasing the speed, one switch to change the direction of the rotation of the motor from counterclockwise to clockwise, and another potentiometer if you want, this is not mandatory, to limit the current, and you can use this potentiometer to avoid damaging your motor if you're worried about excessive current going through it. So you can use a potentiometer to limit the current. So we're going to start by wiring the system, and I'm going to show you how easily you can wire this and how easily you can tune it. This is the wiring that I use for this tutorial, and as you can see, the motor is connected to the output. The power supply is here, connected to the positive and negative. And then the analog inputs are connected like this. There are two potentiometers. One potentiometer is in charge of controlling the speed of the rotation or controlling the torque of the motor, depends on your application. And the other one, which is this line, is in charge of limiting the current, connected to P/F input. There is the direction control switch, which is connected in between the direction pin and the ground pin using a manual switch, and that's it. This is the whole wiring, and by varying the wiper value of these potentiometers by turning them in clockwise or counterclockwise, subsequently, you will have different voltages on these pins, and you will have different speed or torque and also different values of current limit. The next thing you need is a power supply, which I'm gonna use this power supply. It's a battery power supply with variable output voltage and current, and I'm gonna feed this motor with its nominal voltage, which is 36 volt. I'm gonna tune the power supply for that voltage, and I'm gonna set the current of this power supply up to 7 amps. So I'm going to start with the wiring, and I'm going to firstly connect the brushless motor. I've just connected the motor, that's it. What you need to do next is you connect the power supply. I've prepared my power supply with some configuration like this. You can see that the ground of the power supply, the black wire, comes into the switch. There is a switch that allows me to turn on the input voltage to the Solo, and the red wire or the pink wire here defines the positive voltage coming from the power supply. So, and as you can see on Solo, the positive and the negative are shown here. So you should connect the positive to this pin and negative to this pin. Don't worry, if you connect them reversely, nothing will happen because Solo has reverse voltage output protection. I'm going to show you now what happens if you connect it reversely after I turn on Solo. So first I'm going to connect it correctly to the positive to positive, closing the screw, and negative to negative, closing the screw. So I make sure it's 0, it's off. I turn on my power supply. I wait for the power supply to boot up. Now I've connected the inputs to Solo, positive to positive, negative to negative, and we're going to see what happens. So when you turn it on, you're going to see this green light turning on, and this blinking LED, now the light is too much, maybe you can't see it very well, it starts to blink. This is an indication of a correct connection. So I've connected it correctly. I can see the green light, which means this port is connected rightly, and this indicates the whole board is functioning well. But just to show you what happens if you connect it wrongly, these pins, I turn off everything and I reverse the connection. This is totally wrong, but I turn on Solo. As you can see, nothing happens. So this is on, and this green LED is not on, and also the power supply doesn't show any drain of the current. This means that this board doesn't allow the reverse polarity connection. So if you connect it wrongly, nothing will happen, and you can't see this green light turning on. So I'm gonna go back to the previous configuration. So I turn on again, you see that this beautiful green light and also the blinking LED. That's it. Up to now, the motor is wired, the power supply is wired. I'm gonna go to the potentiometers and also the switch, which is here. Now we have done the wiring, and I'm going to go to the speed control mode, and I'm going to start using Solo. So what you should do is, first of all, you need to select the type of the motor you're going to use with Solo now. And in this case, I'm using a normal brushless DC motor, and I want to have 20 kilohertz of switching at the output because this motor works well with 20 kilohertz. And I'm going to put this piano switch here down. This is the piano switch at the extreme left. And after this action, you have actually selected the brushless motor type 1, because also Solo supports brushless motors with extremely low inductance, which in those cases you need to have much more higher switching frequency at the output, maybe much more than 20 kilohertz, and Solo supports up to 80 kilohertz of switching. And I'm going to show you in this tutorial a different type of motor and how you can change between these parameters. Now the motor is selected, and I'm gonna turn on the system. But before that, just to make sure everything is perfectly right, you need to turn back these two potentiometers in a clockwise direction all the way back to the 0. So we've done everything. We've done the wiring, we've done the reset of the potentiometers, and also the type of the motor selection by the piano switch. Everything is done. Now we have to go through the next steps, which are coming after turning on the system. So I'm going to turn on everything, and the green light is okay, the blinking light is down here, everything functions well. The next step will be going to closed loop control. Closed loop control means I'm gonna ask Solo to control this brushless motor in field orient control for me. And in order to tell this to Solo, you need to push down this piano switch. And you saw that for 1 second, there was a vibration on the motor because the motor was floating down here, it moved. There is a little vibration because if I keep it in my hand, you're gonna see it better maybe. You see that? There was a little vibration on the shaft of the motor, and this vibration is the parameter identification of the motor here. So I have already identified the parameters of the motor. The parameters are saved as long as this switch is down, and you can keep the switch down as long as the motor is the same, as long as the system is the same. And I've done the identification. I can do it again, but it's not necessary. The next step will be you ask Solo to go into closed loop speed control for you, because when you push this piano switch down, it's gonna go to the speed control mode. Now, the manual setting of the piano switch is done, and the last thing is tuning the speed controller gains. We have two potentiometers here, KP and KI. Normally, what you need to do is you increase like 5 degrees or something the KP by rotating it in counterclockwise direction. So I turn like 5 degrees KP, and I really don't know if I need KI. I go like 1 degree with KI. KI is a very much more sensitive gain, and you need to increase it carefully. So I've just randomly increased the KP for 5 degrees and KI for 1 degree because this is a step that you have to do with experimentation. Regarding this potentiometer, which is limiting the current, you need to make sure that before starting the application or starting to run the motor, the voltage applied or supplied by this potentiometer at this pin P/F is in line with the amount of current you want inside your motor. The relationship between the voltage at that output, the PF, and the value of current allowed inside the motor is written in our website. And I'm just gonna allow this potentiometer to have some specific current limit. I'm just gonna rotate it in the middle, because in this type of motor and in this tutorial, I'm not gonna go very far. I'm not gonna very push the system. So I'm just gonna make sure this is not zero. So I put it in the middle. The middle, actually, if it's really in middle, is like 2.5 volt, and in the middle, the current limit will be 16 amps. Now I'm gonna start rotating the speed potentiometer, and I'm gonna see how the motor behaves, and based on the behavior of the motor, I'm gonna increase or decrease the gains of the speed controller, and I'm gonna make it perfect for my application. To see the behavior of the speed controller after tuning the current limit, I put it in the middle, so I'm expecting something like 16 amps for the maximum output of the current. I'm gonna turn this potentiometer, which is connected to the speed controller input, and I'm gonna see how the motor behaves, because I'm not sure if these gains I've set here are good or not. And we're gonna find it out. So I increase a little bit the speed, I increase this potentiometer, and I see my motor starts to rotate. But this is not enough. We have to make sure that the speed controller can resist in front of the loads that you apply in the motor. So I apply a little bit of load with my hand. It seems it's resisting. It's not really reactionary, because the gain of the KP could be a little bit more, because KP defines for you how reactionary or how aggressive will be your controller. Now the motor is really good. I can't grab the shaft, and I can go with higher speed, lower speed, and very high speed. Seems perfect. Also very low speed. I'm gonna try. With different speeds, maybe a little bit of KI, just to stabilize it a little bit better. So lower speeds it will behave a little bit better. So I increase a little bit the speed, seems good. It's perfect. You see that it's also moving with very low speed. This is like, I don't know, seems less than 100 RPM to me. So it's all about tuning the gains and setting everything. And as you saw, now I'm gonna change the direction of the rotation with this pin. So I take it out from here. Okay. I'm gonna change the direction of rotation and increase a little bit so by switching this switch, see that the direction is changing completely from counterclockwise to clockwise and vice versa. This is actually really extreme in sense of I'm gonna go to really high speed. I'm gonna change the direction abruptly. You see that it's changing very fast, going back and forth in different speeds, following the reference, and no problem. It's really robust and it can manage all those abrupt changes. I'm going to show you something interesting. This is, as I told you, this is the current limit potentiometer. And I'm going to show you, if I go all the way back to 0 with this potentiometer, I'm expecting 0 current goes to this motor. And what does it mean? This means that I'm expecting the motor to stop. This is not the potentiometer that you control the speed. Actually, the other one is that. So either I should see the motor stops or I should see the motor moves with the required speed. So I'm going to turn the potentiometer in one direction and you saw that the motor stopped. This is an indication that the current was limited to 0. In order to go a little bit further with this experimentation, I'm going to turn it off. I'm going to bring a totally different type of motor. This is a hobbyist brushless DC motor with super fast speed. I think is like 30,000 RPM of a speed. And I'm going to change the motor right now, right here with this motor. This is an industrial grade motor and this is a hobbyist motor with super fast speed. This is 3000 RPM nominally and this one is 30,000 RPM. So extremely different. This one has 16 microhenry of the inductance, which is super low, and this one has around 1 millihenry. Is almost thousands of times more. And we're going to see what happens. We're going to see how it moves and how Solo can easily adapt to such a different motor. So I'm going to rewire this motor to these pins. Before turning on Solo, first I put the voltage of my power supply. So the wiring remains the same exactly. I put the voltage of my power supply at around 10 volt. And I increase the current to much more, like 10 amps from, or 8 amps from the power supply. You know that the amount of current circulating inside of a motor is not the amount of current you drain from the power supply in three-phase motors. There are different types of currents. I'm not going to talk about it now, but I'm putting the current of the power supply to a value that I'm sure that it's enough for this motor, depending on the power that this motor consumes. So we have all the wirings ready. We have the potentiometers, we have the switch, we have the motor connected. Before turning on Solo, we go back again to the normal setting. This motor has a very, very low inductance. So it's totally different with the other motor. I need high switching frequency at the output because to be able to control the current of this motor, I need to put this piano switch up. So this is the motor, the brushless motor type 3 with 80 kHz of switching at the output. So I put it up. The motor has changed, so I need to re-identify the parameters. This is a different motor, so I need to put back the other piano switch also up. The mode remains the same because we're going to stay in the speed control mode. So that would be the configuration when I turn on the system. So I also need to turn back the potentiometers for speed controller. I put them both on 0. Turning them in clockwise direction. So the wiring remains exactly the same, and the only thing I'm changing now is the motor. So let's turn everything on and see what happens. I turn everything on. Of course, nothing happens. The green light is on, the red light is blinking. I need to re-identify the parameters of this motor. So I push back this piano switch down. Boom. There is a identification. Done. Finish. Now I'm gonna increase a little bit the gain of the KP just to help the controller to move the motor. These type of motors, you don't need to actually use KI gains that much. I'm gonna use like KP for 3 or 4 degrees and maybe very, very little amount of KI, maybe like less than 1 degree or something. And then I'm gonna see how these gains are gonna affect the movement of the motor. I'm gonna increase the speed. So it seems that it's not moving. So the gain is very low. KP, increase it a little bit more. Okay, perfect. Seems good now. So I've tuned the gains, and now I'm gonna see how would be the behavior of the motor after tuning the gains. So I've tuned the KP and I've tuned the KI, and I'm gonna see how the motor behaves in this condition. I increase a little bit the speed, and you see that the motor goes all the way up to very high speed. And you can see from the sound, it's a very fast motor. And I'm gonna change the direction of this motor as well. You see that? Super fast, but still the direction change works well. So, now I'm gonna show you a plot of speed versus torque and what happens when you change the direction abruptly in solo, and how we can manage to control the torque and the speed at the same time. So as you can see, while the speed is fixed now, the amount of current and also torque of the motor is almost steady, and whenever we are having some direction change, you see that the plot of the speed rising up and down, while the torque for a short time goes into higher amounts, a little bit of regeneration, and then comes back. And this is just to show you how Solo can manage abrupt changes of the direction change. The values you see here as the amplitudes are per unit values. So for the current, you have to multiply these values to 32 amps, a constant value of 32, and for the speed you have to multiply these numbers to 1200 RPM. In other tutorials, I'm going to show you how to control the torque of your brushless motors with exactly the same configuration, and how can you do it without having any external modules or any external controller like Arduino or Raspberry Pi or anything else. Thank you so much for your attention.